Hello and welcome back. Today I'll be talking about how to find the distance between two parallel lines. Some people might argue that there could be any distance between two parallel lines, but the distance will always have to be above a certain number, which we can call x. For example, if we have these two parallel lines here and a line with length 5, we can see that the line with length 5 will never touch the other line, no matter what we do. But when we draw a perpendicular line from one of the parallel lines, we can see that we have the shortest distance between these parallel lines. This means that any distance between two parallel lines has to be above this certain number, and in most tests, you'll be asked to find this number, which is where the distance formula for parallel lines comes into play. The distance formula for parallel lines is the absolute value of c2 minus c1 divided by the square root of a squared plus b squared. You might be wondering how we would get these values. Many people are familiar with the slope-intercept form y is equal to mx plus b. This is basically that formula, but we arrange it into the standard formula and we use ax plus by plus c is equal to 0. If we had the equation y is equal to 2x plus 3, we could rearrange it into 2x minus y plus 3 is equal to 0. Then, we would plug these numbers into the formula. Let's try out a practice problem with this. We're given the lines y is equal to 2x plus 3 and y is equal to 2x plus 9, and we have to find the distance between these lines. First, let's arrange the formulas to match the standard form. We simply have to subtract y from both sides, and we now have 2x minus y plus 3 is equal to 0, and 2x minus y plus 9 is equal to 0. Let's plug these numbers into the equation. For the c2 and c1, we know it's going to be 3 and 9, as they're the only distinct variables in these two equations. These numbers are also the y-intercepts of both of these parallel lines. 9 minus 3 is equal to 6, and the absolute value of 6 is still 6. Then we have to take a squared and b squared and add them together, which would be 1 plus 4, which would be 5. The square root of 5 is around 2.23. Knowing that, we simply just have to do 6 divided by 2.23, and we get our answer to be around 2.7, which is the distance between these two parallel lines. Now that we know the basics, let's try to apply this for an AMC 10 problem. The question is, the interior of a quadrilateral is bounded by the graphs of x plus ay squared is equal to 4a squared and ax minus y squared is equal to a squared, in which a is a positive real number. What is the area of this region in terms of a, valid for all a values being higher than 0? This question is basically asking us to find the area of the quadrilateral formed through the intersections of the two graphs shown here. Let's start by sorting out our equations. For the first equation given, we have x plus ay whole squared is equal to 4a squared. Let's start by taking the square root of each side, and now we have x plus ay is equal to plus or minus 2a. We can subtract the 2a from both sides to get x plus ay minus 2a is equal to 0. However, we have to keep in mind that it's plus or minus 2a, since we took the square root of one positive term, which in this case was 4a squared. This means that we could have also added 2a to each side, and we can also get x plus ay plus 2a is equal to 0. We now have our first two equations. For our second equation, we do the same steps. Take the square root of each side and we get ax minus y is equal to plus or minus a. Solving for both scenarios gives us ax minus y plus a is equal to 0 and ax minus y minus a is equal to 0. Now, before we start, we have to determine what kind of quadrilateral this is, and we can do that by finding the slopes of each equation. For the first two equations, we can subtract ay from both sides, and then divide by negative a, and we get y is equal to negative 1 over a times x plus 2, and y is equal to negative 1 over a times x minus 2. We can see that our slope is going to be negative 1 over a for both equations. For our last two equations, we can just add the y to the other side and see that our slope is a. We can see that our two lines have opposite reciprocals of each other, meaning that they are perpendicular lines. This works for all the other equations, meaning that we have a quadrilateral with 4 right angles, meaning that we have a rectangle. Now we know that we have to simply find and multiply the length and width of the rectangle to get the area. Our first distance would be from the first two equations. We subtract 2a from negative 2a and we get 4a. Our a squared and our b squared would be 1 squared plus a squared. We then add the square root symbol over that. We can then finally divide 4a by the square root of 1 plus a squared, which would be our first distance. Our second distance would be subtracting a from negative a, giving us 2a. We then divide that by the square root of a squared plus 1. Our second distance would be 2a over the square root of a squared plus 1. Our quadrilateral is a rectangle, meaning that we now just have to multiply these lengths and widths for the area. 2a multiplied by 4a gives us 8a squared, so we have the numerator. We can rearrange the square root of 1 plus a squared to the square root of a squared plus 1. We know that the square root of a number multiplied by the square root of the same number removes the square root, meaning that the square root of a squared plus 1 multiplied by the square root of a squared plus 1 is just a squared plus 1. Our final area is 8a squared divided by a squared plus 1, which is this answer over here. Thank you for watching. If you have any questions, please leave them down below and I'll be happy to answer them.